Well, hello. The next video in our series goes into Chapter 6, the Law of Sines. In the Law of Sines, we're concentrating now on being able to solve oblique, that is to say, non-right triangles. We already know all about how to solve right triangles with sine, cosine, tangent, etc. So here's a picture of an oblique triangle. The first thing is labeling conventions. We want to use capital letters to name the points at the vertices. And so I'll just use A, B, and C for those. And then we want to use small letters to label the sides. And so we tend to use a small a to label the side opposite angle A, and a small c to label the side opposite capital C, and a small b to label the side opposite angle capital B. This is a labeling convention. In other words, it's a good standard way of labeling triangles in solving triangles problems. And the letters don't have to be A, B, and C. They can be X, Y, Z, P, D, Q, whatever. But we always follow the convention of putting small letters opposite capital letters. Now, in order to use the law of sines, we need to have at least one side and two other parts, that is, sides or angles. And this gives rise to cases that we can solve. We can solve the angle-side angle case, where there are two angles and a side included between them, just like in geometry when you were proving congruent triangles. Or the angle-angle side case, where there are two angles and a not included side. And I'll show you examples of some of these in a minute. These are the two cases we can solve using the law of sines completely. There are two other cases, SSS and SAS. We're going to need a different technique to deal with those, the law of cosines, which will be dealt with in a future video. And then there's also the mysterious ASS case, which is called ambiguous by mathematicians. And we'll be getting into that more in the next video after this one. So right now I want to kind of show you what the law of sines is and how it's arrived at. In this triangle, what I want to do is drop a perpendicular down from C, and I'm going to label it H. And that'll be the height of this triangle. So I'm going to make a perpendicular, I'm going to make a right angle there. Sorry for the crudeness of that line. And then using my elementary trigonometry and the triangle that's on the left here, this triangle over here, I could say that the sine of A is H over B, so that H is equal to B times the sine of A. Hopefully you can see that. So that H is equal to B times the sine of A. And then I can do the same thing with this triangle on the left. I can say that H is equal to A times the sine of B, because the sine of B would be H over A. And since these two things are equal, they're both H, I can set them equal to each other. So I can say that B sine A equals A sine B. And then I can divide both sides by sine A and sine B. And when I divide this side by sine A, it's going to cancel out, and it's going to appear over here. And when I divide this side by sine B, it's going to cancel out over here, and it's going to appear over here. So these are divided out, and the final result is that B is to the sine of B, capital B, as little a is to the sine of little a. And this result is known as the law of sines. I can also, if I want to, just want to get some room here, I can also, if I want to, do the same thing. I'd have to redraw this triangle up here, but I can also show that this is the same as C over the sine of C. You can compare any pair of opposite sides and a side opposite an angle in this manner and match it up with another pair of sides, a pair of sides in opposite angles. And this gives us a nice mathematical expression that we can use. The other thing about this that's nice is you'll see is that we could also invert all these. We could look at their reciprocals. So if we wanted to, we could do sine of capital B over little b equals sine of capital A over little a, which in turn is equal to the sine of capital C over little c. So that's another possibility for law of sines. Of course, in practice, you would only use two of these. It depends on the triangle that you're solving. And I think we'll take a look at an example of that right now. So here's a triangle. Now, a good idea when you're doing one of these problems is to make a rough sketch of the triangle and label it. It doesn't matter what it looks like. So I'm going to say that in this problem, angle C is 102 degrees, and angle B is 36 degrees, and little b is 28 feet long. If there are no units, then the problem is unitless. But if there are units, then we carry those through the problem. Well, we have one side, so we can solve this. And we should just label this somehow. So I'll just call this angle C here, and this is the 102 degree angle. It really doesn't matter. And then I don't know this side opposite, so I'm going to label that with a little c. And then, let's say this angle up here is B, 36 degrees. You see how I'm labeling everything. And little b is opposite that, little b, which is 28 feet. So I'll just jot that down right down there. I'll do it this way. This is 28 feet right here. So what do we want to do here? We want to solve this triangle. We want to solve the triangle, which means we want to find all the missing parts. Solve. Find angle A, little a, and little c. That's what I want to do here. Okay, so right away off the bat, since we have a side, well, right away off the bat, the first thing to find is going to be angle A, because we've got two angles, and we know how three angles of a triangle are related. So angle A is going to be equal to 180 degrees minus the sum of 102 and 36, because we know that the three angles of the triangle have to add up to 180 degrees. And so this is 180 minus 138, or 42 degrees. So that's angle A. I'm going to circle that first part. Angle A is 42 degrees. And I can come up here, and I'm going to switch colors because I can come up here and pencil in 42 degrees. And I see I never labeled the A from the beginning, and that was a mistake on my part. I should have labeled A and little a when I was labeling the triangle, because these are the things I want to find. I found angle A. Now let's set up a proportion to find, using the law of sines, to find, let's find little c next. So to find little c, I would put little c over the sine of 102 degrees and set that equal to little b, which is 28 feet, over the sine of 36 degrees. I could have also used angle A, but I don't know this side that's opposite angle A yet, so this proportion would not have been as good. In fact, it would not have worked out at all. Now, one thing you want to do when you set up these problems is you want to make sure that make sure that the variable, the thing you're trying to solve for, is in the numerator of one of your one parts of your law of sines. This will make it easier to solve because now this means that c is equal to the sum. This means that little c equals 28 times the sine of 102 all divided by 36, sine of 36. And now I can go to my calculator. Okay, I got my calculator opened up here. Now the calculator has a fraction template here. It's control divide, and it gives you, it sets you up with a numerator and a denominator. And I can just type in, for my numerator, 28 sine 102 and in the denominator, sine 36. And then I can just type control enter, and there it is. So 46.5955. We're going to round off to the nearest tenth here. So I'm going to switch back to my work here, and C is 46.6 degrees. I'm sorry, not degrees. C is 46.6 feet. That's what it would be, feet. And I'm going to circle that. So I've got little capital A and little c and little a. And now let's use the law of sines. I can fill in up here that c is 46.6 feet. And I can fill in little a. You want to avoid using results that have been rounded. As much as possible, you want to stick with results that were given to you, because those are known to be as exact as you could get. So I'm going to stick with this 28 and sine of 36 combination. And this time to find a, I'm going to put little a over the sine of 42 degrees. There's no avoiding using 40 to 42, but that was exact because I didn't have to do any rounding. And I'm going to make that equal to 28 over the sine of 36. And now here's where we can begin to exploit the power of our calculator. If I go back to that calculator, I already have something that looks very much like what I want. So I'm going to go up with my arrows and go up, and then I'm just going to press enter to capture that last thing I typed in. And then I'm going to use my arrow pad, my keypad, to get in there and just edit and change what I want. Now, as far as what I want is concerned, A is going to equal 28 times the sine of 42 over 36. I think you can see over the sine of 36. I think you can see how that's going to come about from the little algebra that's there. So I'm going to enter that expression, or I'm going to edit the previous expression that I had to be 28 sine 42 over 36. So I can go back to my calculator, and you'll have this on your handheld, and I'm just going to go and delete the 102 and make it a 42. And then I'll have 28 sine 42 over sine 36. And control enter gives me 31 point, well, I'm going to round that to 31.9. 31.9 feet. And now I've completely solved the triangle. I have values for all 6 parts, all 3 angles, and all 3 sides.